In this video, we will determine several limits, and we will approach these from a very intuitive perspective, and we'll bring a bit more rigor through some things that we call limit laws in the next section. But for now, what we're going to do is make use of just algebraic simplification and thinking from an intuitive perspective. So for this first example, let's look at the limit as x approaches 3 of x squared minus x minus 6. So the observation is that the function is undefined at 3. So we can't directly think about just replacing each x with 3. We want to know when x is close to 3, what are those function values going to be close to? So what we are going to do is instead factor in the numerator. And when we factor in the numerator, x squared minus x minus 6 is x minus 3 times x plus 2. And now the x minus 3 terms in the top and the bottom cancel. And we are left with simply the limit as x approaches 3 of x plus 2. And now this is something that's substantially easier for us to answer. Just from a very intuitive perspective, we think when x is close to 3, x plus 2 should be close to, what? 3 plus 2, which is 5. So in words, when x is close to 3, x plus 2 is close to 5. We can also see this from a graphical perspective as well. If we were to graph the function y equals x plus 2, that is a line with slope 1 and y-intercept 2. So y-intercept 2, slope 1. So roughly speaking, the line looks something like this. And on the line, we have the point 3, 5. And we see that if we input values of x close to 3, if we follow up to our graph, we see that those values, or the outputs, will be close to that number 5. So a similar problem here. Let's algebraically simplify and then evaluate. So once again, what we have in the numerator is going to factor very nicely. It's a difference of squares. So x plus 3 times x minus 3 all over x minus 3. The x minus 3 in the top and the bottom cancel. And we are left with the limit as x approaches 3 of x plus 3. And once again, what is the question that is being asked? When our inputs are close to 3, what is x plus 3 going to become close to? Well, if x is close to 3, x plus 3 is going to be close to 6. So the value of this limit is 6. And just like in the previous example, we could sketch a graph and think about this graphically as well, but I think the intuitive perspective is what we are going for. For an input close to 3, the output is going to be close to 3 plus 3. Let's investigate another very familiar example. The limit as x approaches 0 of the expression here. Once again, the observation is, we are undefined at 0. But when we are taking the limit, we are not concerned what happens here at the point 0, just points really close to 0. So the obvious algebraic simplification is that each term that we see in the numerator contains an x squared. So let's go ahead and factor that x squared out. So the limit as x approaches 0 of x squared over x squared plus 2x minus 1 all over x squared. The x squared term in the top and the bottom cancel. And we are left with the limit as x approaches 0 of x squared plus 2x minus 1. And once again, remember the question that is being asked. if we are going to input a value of x really close to 0, what will the output here become close to? Well, if x is close to 0, x squared is close to 0, and 2x is close to 0. So 0 minus 1. So for an input close to 0, our output is going to become close to minus 1. And the value of this limit is minus 1. To help aid you in seeing this visually, what I would recommend is going ahead and pulling out your graphing calculator, graph the function y equals x squared plus 2x minus 1, and then look at its graph and see, what are those outputs close to when x is close to 0. One more very similar example, and something that we're going to see quite a bit more of in future sections. If you recall back to a previous section, this quantity we are taking the limit of is something that we referred to in the past as kind of a difference quotient. But let's go ahead and investigate it. I want to take the limit, let's algebraically simplify, and see what we are left with. So algebraically, all that I can do in the numerator is expand out. 2 plus h quantity squared is going to be 4 plus 4h plus h squared. We're subtracting away 4 and dividing by h. So right away we see things are going to work out very nicely. 4 minus 4 cancels. What we are left with in the numerator are two terms that involve an h, so we can go ahead and just pull those out. So the limit as h approaches 0 of h times 4 plus h divided by h. Cancel off the h's that are in common, and now we're left with something which is much more familiar. The limit as h approaches 0 of 4 plus h. Once again, the question is, for an input of h close to 0, what is 4 plus h close to? Well, if h is near 0, 4 plus h is close to 4. So we would say that the value of this limit is the number 4. Let me also note a very important thing here is that we've used good notation throughout. As you work through these problems, you should make sure to write your equal sign at each step. We rewrite our limit at each step until we think about taking that limit. In between, what we're doing is the algebraic simplification, but we need to just write down at each step what it is we are looking for in the problem.